NASA is working on an even bigger Mars helicopter. Is dark energy just an illusion? A particle that only has mass when moving in one direction, and the Parker Solar Probe completes its closest flyby of the sun. All this and more in this week's Space Bites. In our 2024 wrap-up episode, we talked about the Ingenuity helicopter on Mars and how it completed its final flight in the first couple of weeks of the year, and how we finally found out what happened to it at the end. And over the course of its time on Mars, Ingenuity flew for 72 flights, which is way beyond the 5 flights that NASA had originally planned. And of course, on its final flight, it landed hard, broke its rotors, and it would never soar in the skies of Mars again. But obviously, this was an amazing idea to send a helicopter to Mars to fly in the thin Martian atmosphere. This should be a standard attachment for any future mission that's going to Mars, right? But what does a beefy version of Ingenuity look like? And this week we saw some new pictures coming from NASA of the Mars Chopper.
Get to the chopper!
This is their idea of what could be a more capable, bigger helicopter that could fly in Mars. So take a look at the Mars Chopper. This is just an artist's illustration, a rendering of what this thing could look like. But it is about the size of an SUV, of a small truck. And it would have 6 separate rotors, and each of the rotors would have a 6-bladed propeller. And so then this helicopter could lift off of the surface of Mars, could carry a 5-kilogram payload of science instruments, and it could probably fly for about 3 kilometers. And so the idea would be that this thing would have a pretty significant science payload allowed to observe, to take images from above. It would be able to fly 3 kilometers at a time and cover a lot of ground, helping to explore areas on Mars. So hopefully we will see this fly in the skies of Mars in the future. Is dark energy just an illusion? Dark energy was first discovered in 1997, and this was an observation that astronomers made. They were trying to measure the expansion rate of the universe, and they were looking at a very specific kind of explosion called a Type 1a supernova. And we know that the Type 1a supernova has a sort of set amount of mass when the star goes off. And so because you know how intrinsically bright the explosion is, you can measure how far away this explosion is based on how bright you see it in your telescope. And this was a Nobel Prize winning discovery that in fact, the universe is not just expanding, but this expansion is accelerating. Now, once this first discovery was made of dark energy, astronomers have been trying to find out the source, trying to measure it, map it, try to explain what's going on. And this became more complicated with this thing that's known as the Hubble tension. And so astronomers were measuring this expansion rate of the universe relatively nearby, looking at nearby galaxies, looking at Type 1a supernova, and they got one measurement for the expansion rate of the universe. And then they looked at the expansion rate of the universe based on the cosmic microwave background radiation and got another very precise number. And the two numbers aren't the same, and they don't overlap. And so either there's a measurement error or there's some kind of new physics that's going on, that the expansion rate of the universe has changed over time depending on when you're measuring it in the universe. So a new paper has come out that confirms an interesting idea that's been proposed over the last couple of years, that dark energy just doesn't exist. It's an illusion. Before I get into this paper, I want to set the stage and sort of explain the concepts leading up to it. So when we look at the universe at the smallest scales, we can see galaxy clusters containing lots of galaxies, and then we can see the voids that are in between these galaxy clusters. And at the smaller scale, say the scale of a galaxy cluster, then there really is a difference in the distribution of matter between the places that have galaxies and the places that don't. But as you sort of move out your scale out to, say, 1 billion light years across, then you can get this kind of average density of material across space itself. And the assumption, one of the sort of core assumptions made by astronomers, is that the universe is homogeneous, that you're going to go, no matter where you go out into the universe, if you measure at the largest scales, you're going to get this similar distribution of matter across the universe. But there's this theory called timescapes, and it was proposed a couple of years ago, and it says that you can't have this homogeneity when you apply it to cosmic expansion in the universe. You might have this homogeneity across distance, but you can't have this homogeneity across time. And this is sort of one of the interesting things that has turned up, is that it appears that dark energy is changing over time. And this idea comes from the possibility that in the places of the greater density, like in those galaxy clusters, the clocks are going to run more slowly compared to the cosmic voids. This is time dilation. And so when you add up these differences in the clock speed over the billions of years of the age of the universe, these numbers start to add up. And this could account for these differing measurements of the speed of the expansion of the universe over time, that you're not seeing this accelerating expansion of the universe, you're measuring this accumulated time dilation over billions of years. And so, like I said, this idea of timescapes has been around for a while, but what happened recently was astronomers took this really interesting survey of a supernova called Pantheon Plus. And I've done plenty of stories about that. I've interviewed the people behind the Pantheon Plus catalog. It is a catalog of thousands of type 1a supernova. They compared the two models, there's dark energy in the universe model versus the timescapes model, and looked at how the observations of the type 1a supernova fit against those two models. And what they found is that the timescapes model is a better fit for the type 1a supernova observations, although it still is applicable to both models. So this is sort of an accumulating evidence that maybe dark energy isn't a thing after all. And in fact, that you can use time dilation to explain how it looks like the universe is accelerating as it gets older. Obviously, this would be groundbreaking. This would be an incredibly exciting discovery. And the good news is that there's a lot of really interesting experiments and observations that are coming out very soon. We've got the Vera Rubin Observatory, which is probably going to find 1 million of these type 1a supernova compared to, a couple of thousand in the Pantheon survey. So that alone will help give a much larger data set that astronomers can use to validate against the two theories. So this is exciting, so stay tuned. A particle that has mass when only moving in one direction. Particle physicists have been predicting that there is a kind of particle that should exist. It's known as a quasi-particle, or a semi-Dirac fermion. It was first proposed about 16 years ago, and researchers say that they have finally seen this in the lab. And in fact, they discovered it by accident. So what the researchers were doing was they were looking at how electrons move in a kind of metal. The metal is called zirconium silicon sulfide. And they chilled this metal down to essentially just above absolute zero. They hit it with an incredibly strong magnetic field, 350,000 times stronger than the magnetic field of the Earth. And then they also bombarded it with infrared radiation. And they were able to get electrons to start moving inside this crystal. And that told them how the electrons were behaving as they were moving inside the metal. And as they increased the magnetic field, they were expecting that the energy levels of the electrons should be increasing in this sort of gradual amount to match the magnetic field. But what they found was that it was increasing in this sort of quantum step level, something that's known as Landau levels. And these have very fixed values. And the movements of these electrons with these semi-Landau levels match the predictions of these quasi-particles. And so what they were finding was that as the particles were moving along one orientation through the crystal, it acted as if it had mass. And then as it was moving along a different orientation in the crystal, it acted as if it was massless, and then back to mass, and then massless. And the way the researchers described this is it's kind of like you've got trains going along a track. On one part, it's a straight line. The train can go as fast as it needs to. And then as it turns, it goes perpendicular. Now it has to move this very windy track. It slows down, has to go through a lot of obstacles. And so with the particles moving in the magnetic field, you're getting this strange behavior, this quasi-particle behavior that had been predicted for 16 years. What can be done with a particle that behaves one way when it's moving in one direction through a metal crystal and appears to have mass, and then it moves in a different way and it doesn't have mass? I'm not sure yet. So I guess we'll have to wait and see how this research progresses. Parker Solar Probe makes its closest approach to the sun. On December 24th, 2024, NASA's Parker Solar Probe made its closest approach to the sun. It came within 6 million kilometers of the surface of the sun. And just for comparison, that works out to about 4% of the distance from the Earth to the sun. At its closest point, it was going 692,000 kilometers per hour as it was going around the sun, which is 0.064% the speed of light. This is the fastest object that humanity has ever sent into space. It made that flyby on December 24th. It sent a message home on December 26th saying that everything was fine. It had completed its observations and it was ready for new tasks. And now it's in its sort of perfect final orbit that's going to allow it to come really close to the sun and then fly away to cool off and then come in close to the sun until the next flyby is going to happen in March, and there's going to be another flyby in June, and hopefully it'll just keep going as long as the spacecraft can survive. Now, I'm sure you're wondering, like, oh, I would love to see the pictures of the sun when Parker Solar Probe was only 6 million kilometers from the surface. And the problem is that Parker doesn't have a camera system in the way you would traditionally understand. If you tried to point your camera out at the sun, it wouldn't survive very well. But it has a camera called the Wide Field Imager for Parker Solar Probe, or WISPR. And it's designed to look at the large-scale structure of the corona and the solar wind. And I don't have any pictures of this most recent flyby, but here's some examples of the pictures that it took back in 2021 as it was flying through the atmosphere of the sun a couple of years ago. And so you would see roughly the same thing with this flyby as well. Every week we do a vote on our channel where you tell us what you thought was the best space news of the week. And the winner for last episode, last year, 2 weeks ago, was overwhelming for the potential for an atmosphere at TRAPPIST-1b. So obviously you are still watching this story very carefully, and I promise as soon as we get observations of any of the other TRAPPIST worlds, I will absolutely fill you in. Now, we post this vote on our channel within about 24 hours of when we release Space Bites. It goes into the community tab. But if you're just scrolling on YouTube, scrolling, you should see the vote come up. So just take a second to let us vote. And of course, as you saw, we used all of the votes for our 2024 year-end wrap-up. And so if you haven't already watched that, it was a great video, sort of a nice reminisce back through 2024. And of course, you want the best chance to see the vote, subscribe to the channel, click on the notifications bell, and then just train the algorithm or be trained by the algorithm. All hail the algorithm. Covering an asteroid with balls. As humanity becomes a true solar system spanning civilization, we're going to need to learn to live off the land, use the resources out in space to help us continue to live in space. And one of the ideal places to get these resources from are asteroids. Now, the small asteroids are going to have minuscule gravity, and so they're really easy to get close to and get away from. I mean, I say easy, but actually it's kind of tricky. As we saw with the Rosetta mission to try and land on a comet, it's tricky in low gravity, but you know, engineering challenges. But the other thing is that there are a lot of near-Earth asteroids that have a very similar orbit to the Earth, and that means that you need a very small amount of delta V, change of velocity, propellant to get you to these asteroids. And so it would be relatively easy to get to these asteroids, relatively easy to land on these asteroids, and extract the resources for your future O'Neill cylinders. But you want to know what you're working with. What is the consistency, the density? What are the chemicals and constituents? What is the magnetic field of this asteroid? So this really cool paper came out from some researchers in Italy where they proposed that you have a mission that lands on the surface of an asteroid and then it spits out dozens of small spherical probes on parabolic trajectories around the asteroid. These balls will fly through space, they will land on the surface of the asteroid, roll to a stop. And as they did, they will be able to form a mesh network around the asteroid that will then communicate back with the lander. And each one of these small balls will remember the trajectory that it took, where it landed, and then that can be used to sort of map out the gravity field of the asteroid as well. They can measure out the magnetic field, they can sort of look around at their surroundings and see any other features. But I like this idea that the spacecraft kind of lands and then spits out all of these little probes that map out the entire asteroid. The quadrantid meteor shower this weekend. So it's time for another meteor shower, and this should be one of the good ones. These are the quadrantid, and they appear early on within the first couple of days in every year. One of the interesting things about the quadrantid is that they come from an asteroid 2003 EH1. Most meteor showers come from comets, but the quadrantids come from an asteroid. The other thing that's interesting is normally when you get a meteor shower, it is named after the constellation where the meteors are originating. And so the Perseids come from Perseus. The Geminids come from Gemini. And so where do the quadrantids come from? Well, they come from a constellation that isn't officially recognized anymore, called Quadrans Muralis, and it's located in between Draco, Bootes, and Ursa Major. And so we have the name of the quadrantids, even though we don't have really an official designation for this constellation anymore. Now, I'm bringing this up because they're a very good meteor shower. You can see about 80 meteors per hour. And it's nicely timed that over this weekend, we've pretty much got a new moon. So there's going to be no light pollution coming from the moon to be able to obscure your view. So starting January 3rd, January 4th, go outside at night and try to see if you can see some meteors from the quadrantids meteor shower. Finally, I want to share some really cool images. The first is an image of dust devils on Mars taken by the Mars Reconnaissance Orbiter. The dust devils were moving in an area called Haldane Crater. And this picture was taken a couple of years ago, but it's beautiful. And it just shows you how busy those dust devils are on the surface of Mars. And planetary scientists are using this as a way to watch as dust slowly envelops and covers up the dust devils. The freshest tracks were laid most recently, and you can watch and see as they change over time as more and more dust accumulates across older dust devil tracks. You know, we're still learning what is the effect of these dust devils on solar powered spacecraft on the surface of Mars. We know that as these dust devils go by, they can actually clean off the solar panels on various rovers and extend their lifespan. And this allowed Spirit and Opportunity to last a lot longer than anybody ever anticipated. And the second thing is not really an image, but it's a collection of images of the 88 constellations in the sky. And the images were taken by an astrophotographer named Eckhard Slawik, and he went to various dark sky locations around the world in both hemispheres and just took perfect pictures of the constellations. And in fact, you can see a 40,000 pixel mosaic of the entire sky from both hemispheres and really look around in 3 dimensions at all the constellations. These images were provided by the Noir Lab, and you can actually click through and go to each one of these constellations. You can see what it looks like either just with the raw stars, but also with the lines that actually make the shape of the constellation. You can learn information about the constellation and then see tons of pictures of all of the different objects that are located in that constellation. And so if you want to learn more about your constellations and see what kinds of objects are where and really see it in 3D, this collection is absolutely incredible. Now, you're watching this week's episode of Space Bites, but I am writing my weekly email newsletter. This contains dozens of stories you're just not going to hear about here on Space Bites every week. For example, New Glenn just completed a hot fire test, and is it about ready to fly? Could habitable white dwarf planets retain their oceans? And using an oil industry framework to map space resources. So I am writing the newsletter. It goes out every Friday to about 70,000 of my closest friends. It's completely free. You can sign up, go to universetoday.com/newsletter. I'm going to talk about my goal for 2025. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Barry Lake Roofing, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, SpiderSwap.io, Stephen Fowler Munley, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons, all your support means universe to us. So I've been mentioning over the last year that advertising revenue to the Universe Today website has gone completely into the crater, that traffic to our website, thanks to Google, has gone completely into the toilet. And this is because now when you do searches on Google, they give you an answer that was borrowed from our website, but they don't actually send people to our website anymore. And so that means that we're having to rely on other sources of revenue. And, you know, seeing this happen being prepared, I have tried to shift everything over to Patreon as a way to fund the salaries of everybody who works for Universe Today. And I feel like we're very close. It's going to be lean for a little bit, but my plans for 2025 is that I want to cut all of the advertising off of the Universe Today website. I want us to no longer be reliant on these whims of various search engine companies, of advertising companies, of sponsors, of social media companies. I want to be able to just create content with my team of space journalists for the people who want to learn information about space. And we are so close. I feel really confident that 2025 is the year when we will finally cut that thread and we will become a true independent space journalism agency, and one of the few. I mean, we're seeing so many traditional and online companies just go out of business because the business model is just not sustainable. And yet I think we can be sustainable and we can remain and try to bring you the best coverage. So if you want to be a part of that, as it sounds important to you, please come and join our Patreon. Go to patreon.com/universe today. And I cannot wait for us to be completely independent. All right, we'll see you next week.